Okay, so hello again. So again, before we continue our discussion, so let me just check if you guys are already ready or in front of your computer. So just give me a thumbs up. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Great. So most of you are already here and ready. Okay, so let's now continue this one. So again, just multiply this equation to 4. So 10 times 4 will become 40. And still a negative minus I1. So 4 times 50 will become 200. And then still negative minus I2. And this one will become 160. So 40 times 4 is 160. Okay, equal to 0. So this is now our equation number 4. Okay, so for this one, this equation number 5, just multiply this one to 5. Okay, so 5 times 20 will give us 100 minus I1. So 5 times 40 is 200. Okay, minus I2. So 5 times 60 is 300 is equal to 0. So this is now our equation number 5. Okay, so were you guys able to follow so far? And how did we get those equations right here? Equation number 5. Okay, just one. What about the others? Okay, great. And then we can multiply this one, okay, into negative, or we can just simply, deduct this one so that we can have 40 minus 100 will give us negative 60, and then minus plus minus, okay, will become positive. So all in all, this will become positive I1 200. So this will be cancelled. Okay, it will give us a 0. And then in here, so negative plus negative will become positive. So uh, positive 300 minus 160 is equal to positive 140. 140 is equal to 0. Okay, so we could now call this one as your equation number 6. Okay, and then in this equation number 6, we can now solve for the value of your I2 since we now have only one unknown. So this one will become negative I60 plus I2 times 140 is equal to 0. Okay, so just transpose this negative on the other side. So it will give us I2 times 140 is equal to 60. Okay, and then simplify this one a little bit more just by putting this one on the other side. So this one will become I2 is equal to 60 divided by 140. So using your calculator, I2 is equal to 60 divided by 140 will give us a result of 0.428. Okay, or 429 rather. You're going to uh, round up the 8 into 9. Okay, so 429 ampere. So this is now the value of our I sub 2. So were you guys able to get this one? And how did we get the value of I2?
Yes, sir.
Okay, great. So we now have the I2. So we can now also eliminate the I2 right here for us to be able to get the value of I1. So how do we do that one? So we can do the same method. So we have to make this one equal to this one. So to do that, so you have to multiply the equation number 4 to 3 and then equation number 5 to 2. So 2 times 6 is 120 and then 3 times 40 is 120. So for the equation, let me get this one. And then let's place it right here. Simultaneous equation for the 4 and 5, still 4 and 5, but in here we now have to eliminate the I2 for us to be able to get the value of I1. So in here, this will become times 3, and then the equation number 5 will become times 2. Okay, so doing that one, our equation number 4 will become 3 times 10 is 30 minus I1, 50 times 3 is 150 minus I2, 40 times 3 is 120 is equal to 0. Okay, so this is now our equation number 4. So just let me know if I did something wrong. Okay, and then for the second equation, or equation number 5, so just multiply this one into 2. So 20 will become 40 minus I1 times 80 minus I2 times 120 is equal to 0. This is now our equation number 5. Okay, and then we can now deduct this one for us to be able to eliminate this I2 right here. So negative 40 plus 30 is negative 10, and positive 80 minus 150 is negative I1 times 70. Okay, and then this one will now be eliminated, of course, since negative 120 plus 120 is equal to 0, and then equal to 0. So now is your equation number 5. Okay, so again, you can now simplify this one a little bit more for you to be able to get the value of I1. So just transpose this one on the other side. So I1, see, so we can also do that one. Okay, let's just make this one positive I1. I1 times 70, okay, is equal to negative 10. Since the one that we transpose is this expression right here. And then from here, I1 will become negative 10 divided by 70. So I1 is negative 0.7 ampere. Okay. So as you guys can see, we've got a value of negative in here. It only means that our assumption on loop number 2 is incorrect. Okay. So our loop right here should be clockwise, not counterclockwise. Okay. So we have a loop clockwise and then another clockwise right here. So that's the correct rotation of this current right here. So in here, if you've got a result of negative 0.7, then this one is still correct. Okay, just make this one positive and then just change your polarity from counterclockwise into clockwise. Okay, so no need to worry if you've got a value of negative. It only means that you have an incorrect assumption of loopings. Okay, so are we clear so far on how did we get the value of I2 and I1?
Yes, sir.
Okay, great. So going back to our first equation, equation number 1. So as long as we know the value of I1 and I2, then we can now solve for the value of I3. So since we now already have the value of those I2 and I1, then we can now solve for the I3. So I1 plus I2. So I1 is negative 0.7, okay, plus I2 is 0.429. Okay, so take note, you still have to, get the signage. Okay, do not make this one positive yet. So I3 is now equal to, so negative 0.7 plus 0.429 will give us a result of negative 0.271. Okay, so once you've got already the all of the values of your currents, and that's the time that you can now change this one into positive. So I3 now is equal to 0.271. Okay, so meaning this I3 right here is also incorrect. Okay, so instead of leaving, this one is actually entering. So that's the correct assumption when it comes to this polarity of I3. So we have I1 entering, I3 entering, and then I2 leaving. So that's the correct assumption when it comes to those currents. Okay. So voila, we now have the result for the I3. So the correct answer for this 40 ohm resistor, okay, so the current that is flowing is 0.271 ampere. Okay. And if we are going to compare that one with our solution, so in here we have two super nodes, but either of those two they are just the same. Again, just like what I mentioned a while ago. So at node A or at node B. So it will give you this equation right here, wherein they are just the same. And then we have those three loops, okay, which is the same with what we have. Okay, just analyze this one again. And then in here, we've replaced the let's say this, where is that one? This I3. Yeah, this I3 right here into a I1 plus I2. And then got this new values right here, or this newly expression. And then you can now use those expression for you to be able to get the value of I1 and I2. But in here, I didn't use simultaneous equation, but I did use the calculator. But of course, you can use that one just like what we did a while ago in here. This is the longer method, simultaneous equation 4 and 5, simultaneous equation and 4 and 5. Okay. But if you want to do the short method, okay, so as long as you know the final equation of your this one and this one, then you can now use that one and then use your calculator for you to be able to get the I1 and I2. So just look for the function. Uh, where is that one? Look for the function. So in my case, I'm using the Casio FX991EX, and then just by clicking the mode or setup, uh, I can find here the equation or func, F-U-N-C, okay, or function. Okay, so just go over on that one. Okay, and then you'll be given a choice as we're in to give a simul equation, and then the other one is polynomial. So just choose the simul equation, and then after that you will choose how many unknowns that you have on that equation. So since we only have two unknowns, the I1 and then the I2, then I will choose two unknowns, and then it will give you this. So of course you guys cannot see. However, I have a demo, I guess, in here. Mm, 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 mm. I think I wasn't able to put a demo. Okay, let's just find it on YouTube. So how to use simultaneous equation in calculator. So of course we have different versions of calculator. Just find for a specific version of your calculator. So you can find here the 991ES or the 991EX, which the one that I have in me right now. So let's go over with this one if you have this kind of calculator. So for example, you have this equation right here, equation number one and equation number two, and then you also have two unknowns, the x and y, and then x and y. So just click mode and then click number 5 for the EQN or equation. And then we have here four different syntaxes. So since we only have two unknowns, you have to choose the number one. ENX plus BNY is equal to CN. So this is your ENX, and then this is your BNY, and then this is your CN. If you're going to choose the number two, meaning you have three unknowns, okay, the A, B, and C. All right. And then the rest are another format or syntax, but mostly you're only going to deal with two unknowns or three unknowns. Okay, but you can have up to four unknowns. Okay, just by choosing the number four, I guess. By the way, can you guys hear what is my screen saying? Can you guys hear anything?
No, sir.
Wala, wala. Okay, so I think it's right here. Well, anyway, so just watch this one. Just find it on YouTube. So how to use simultaneous equation calculator. So after clicking the number one, it will give you this one. So just click the value of your the first value, which is 3. So 3 and then equals. And then the second one is -2. So you have to negate that one also. -2 and then equals. Okay, and then the last one is +6. So 6 and then equal. Okay, so do the same on the second equation. So 5 equal, and then it will give you to the it will lead you to the second expression, which is the letter B. So +6 equal, and then the last one is 38 and then equal. Then after that, if you're going to press equal, it will give you the values of your x and y. So in here, the solved value from the calculator, x is equal to 4, and then y is equal to 3. Okay. So I would like you guys to do this one also, because this is the faster method, actually the fastest method, okay, by using the calculator, okay, as long as you have the correct equation, of course, then you'll be able to get the value of those unknowns, the I1 and then I2 right away, okay. So I will leave this part to you guys, since I'm not sure which calculator you're using. So you guys have different versions of calculator. So you're the one who's responsible to find a specific tutorial on how to use the equation on that calculator of yours. Okay, and then after that you will get these results right here. Okay, so we have here the I1, which is -0.143. Let's compare it. Oops. And then the other one is 0.429. 0.429. And why did we get a different result in here? -0.143. Hmm. But we've got the correct answer, which is 0.271 or the 0.28. Just has a little variation. Okay, 0.286. So I think the assumption right here, or the the polarity of the one that they've used, is the uh, entering part, or the entering symbol, which is the negative, and then this one will become positive, and then this one will become positive again. So negative, positive, positive. Um, Either of those two, so you will get the same correct answer, okay, which is 0.286. So since we have two different results, wherein I've got -0.7, and then the other one is the same, which is 0.429. Okay, so I would like you guys to recheck, okay, uh, what differs with my solution right here and then my solution right here right now. Okay, well, anyway, since we don't have enough time anymore, and then we cannot go back in here and then analyze everything again, so I will leave this one to you guys. And then if you want to get the voltage drop across RT, then just get the value of that I3, which is 0.286, and then the resistor on that I3, which is 40 ohms, and then you will get 11.44 volts. Okay, so yeah, that's it for the example number one. So any questions so far?
Answer.
Okay. So I hope the others were at least able to get 50% of the idea or the process, and how did we get the 0.286 right here. Anyway, so that's it for the example number one. So here's just a more explanation on how you execute the process of Kirchhoff's circuit law. So the first one is you know, the most common thing that we do, but either of those step 1 or step 2. So uh, you can interchange those two. Okay, as long as you have already mastered the things that you guys need to do, especially in solving a Kirchhoff's circuit law, okay, or Kirchhoff circuit diagram. So in here, we will just assume all voltages and resistance are given. If not, label them V1, V2, R1, and R2. But in our case, it's already given, so we don't need to do that one. Okay, so that is why we have already jumped onto the number 2. Okay, but in here, it's also already given the clockwise or the anti-clockwise. So step 1 and number 2 is already done. And then step number 3, so label each branch with a branch current. So in here, it's also done, which is the I1, I2, and I3. So they are already labeled. And then the things that we did now, which doesn't exist in here, okay, is the KCL, which is now uh, step number 4. And then after KCL, it's now the KVL. Okay, and then after finding the equations, equation number 1, 2, 3, and 4, or how many equations that you can now try to eliminate some of the equations by using the simultaneous equations. Okay, to solve the unknown variables. Okay, so yeah, you can do any of this one right here. So the important process right here, you have to do the KCL first before the KVL. Well, actually, you can do also KVL first before the KCL. So there is no, you know, uh, absolute process or step when it comes to solving a Kirchhoff circuit law. Okay, as long as you know what you're doing, you can do uh, any step right here first. Well, except the step number 6. You cannot do a linear simultaneous equation if you don't have the given equations. Okay, so that's why you have to do the there's first 5 steps before you can do the step number 6. All right, so that's it for the process. So here's more explanation when it comes to using Kirchhoff's circuit law. So again, we have this law right here is uh, for us to be able to calculate the various voltages and currents circulating around a linear circuit. So we can also use loop analysis to calculate the currents in each independent loop, which helps to reduce the amount of mathematics required by using Kirchhoff's laws. Okay, so this one is super similar also with the Ohm's law. So whatever you can do in Ohm's law, you can also do that one on the Kirchhoff circuit law. So you can find the individual voltage drop, individual uh, current, etc., etc. Okay, just a different method. So the same with this one. So I will skip this one since this is just another explanation how to use or how to apply KVL or KCL on a complicated circuit. So let's have this second example now. So in here, where is that question? Okay, but the question right here is we have to find the individual voltage drops, okay, and then the individual currents at the same time. I1, I2, I3, I4, and then I5. Okay, so if you guys are going to take a look at this one, we can easily combine this one using the parallel uh, circuit law. The same with this one, the parallel circuit law. And after that, you will have a single series path or single series circuit diagram. Then after that, you can now find the I total. Okay, so that's the way wherein for you to be able to verify what is the value of your I total. You can also apply the KCL right here. Okay, so if you guys are going to take a look on this one, you can apply it on this part or on this part. Okay, so we have I1 and I2 entering. Okay, and then IT, which is leaving. So of course, I1 plus I2 is equal to IT. So the same with this one on the right side. So we have IT entering on this node right here, and then we have I3, I4, and then I5 leaving. So if you're going to analyze this one, also we have uh, IT as your positive, and then I3, I4, I5 as your negative. So of course, if you're going to divide this one into 3, it is still the same if you're going to add those 3 individual currents right here. Okay, so those are the ways. But in here, what we simply did is we combine these two and these three into one value. Okay, so this is the computation for the RAC, and then this is the computation for the RCF. So after that, we can now get the total resistance. So 1 plus 10. Okay, so that's your total resistance. So that is why we have RT is equal to 11 right here. And then for the VT, we have 132 volts, which is the original voltage source right here. So since we are getting the I total, so we have to get the total values of your voltage and then R total. So 132 divided by 11, you'll get 12 ampere. Okay, so that is now the value of your IT right here. So after that, you can now have this one, of course, after simplifying or getting these values right here. So we have I total 12 ohms. The first one is 1 ohm. Second one is 10 ohm. Okay. And then after that, you can now solve for the individual voltages. Okay. So in here in the RAC, of course, we only have one voltage that is flowing since they are in parallel connection before. The same with the RCF, those three branch, we now have a single voltage value. So that is why if you guys are going to take a look on this one, I1 and I2, we have the same numerator. So that is the voltage that is flowing on the uh, I1 and I2. And then for the I3 up to I5, we also have a single value for voltage since they are in parallel. So now, how did we get those 12 right here and then 120 right here? So this one came from this circuit right here. So remember how to get the oops, how to get the individual voltage. So for us to be able to get the individual voltage, so we have to use this formula. V1 is equal to I1 times R1. Okay, so I1 is equal to your IT since we now have a series connection, which is 12 amps. R1 is 1 ohm. So V1 now is equal to 12 volts. Okay, so this is now the value of your RAC or V1 and then V2. Okay, so that is why we have the same value of your I1 and I2 for the voltage across them. So V1 is 12 volts and then V2 is also 12 volts. So that's it for this part right here. Okay, and then for this part, so the same concept. So we have V2, let's say this is your second voltage drop is equal to I2 times R2. Okay, let's just say that this RCF is your R2. So I2 is still 12 amps. Okay, since again we have a series connection. So all of your values of your currents are the same. So V2, why is it lagging? V2, so I2 is 12 and R2 is 10. Okay, so V2 is now equal to 120 volts. Okay, so this one is also the same with, my bad. So let's just make this one V3. Okay, and then this one is R3. V3. So this one is equal to your V4 and then V5 since we have three branches on that one. Okay, so your V1, V2, V3, V4, and then V5. Okay, so 12 volts for the V1 and V2, and then 120 volts for the V3, V4, and then V5. And then just substitute that one using these formulas right here, and then you will get those individual currents. So 12 divided by 2.4, which is the R1, you'll get 5 amp, and so on and so forth. Okay, and then using the KCL for you to be able to verify if your results right here are really correct or no. So you can have this one. Okay, so I total is equal to I1 plus I2, which is this one, or you can have the I total is equal to I3 plus I4 plus I5, which will be coming from here. Okay, so I1 plus I2, 5 plus 7, so it's equal to 12. So that's actually correct for the values of I1 and I2. How about the I3 and I4 and I5? So 2 plus 6 plus 4 is also equal to 12. So with that, you have already verified that your values of your I3, I4, and I5, and then I1 and I2 is actually correct. Okay, just by using the Ohm's law in here. And then this one is with the use of the KCL. Okay, so are we clear so far? Were you guys able to follow? What about the others? Okay, 80%. Okay, so you might get somehow lost. Okay, especially if I didn't show everything. Well, anyway, as soon as you're going to review this one, you'll be able to understand everything, hopefully. Okay, just by reading everything in detail. Okay, this one, the explanation, and then this circuit right here, and then those more explanations, and then the you know computed values, etc., etc., and then how to check it using KCL, and then more explanations, etc., etc. Okay, but anyway, that's it for the example number 2. So let's now move on to example number 3, since we don't have enough time anymore. So in here, find the currents flowing around the following circuit using Kirchhoff's current law only. So take note, we only have to use KCL, okay? So we can actually use Ohm's law right away right here, just by combining those two using the parallel law or parallel rule circuit. But since we are restricted to that one, so we have to show the Kirchhoff's current law, okay? But before we can do that, we have to apply KVL also at the same time. Okay, so let me just get this one. Okay, so in applying a KCL, so that's super simple. So we can actually find the KCL equation right here, since we have entering and then two leaving. Okay, so just find the node wherein there is a current that is entering and then a current that is leaving at the same time. Okay, so that's the way for you to be able to know where to start doing your KCL equation. So KCL at node B. Okay, so in here we have I1 is positive minus I2 since they are this one is living, and then the same with I3 since that is also living. So if you're going to simplify this one a little bit more, it will give us I1 is equal to I2 plus I3. So this is now our equation number 1. Okay, so clear so far on how did we get this equation number 1? I1 is equal to I2 plus I3. Okay, so super simple. The next one after KCL is now, of course, the KVL. So we can have a loop right here inside. Let's call this one loop number 1, or loop on the outer side. Okay, let's call this one loop number 2. So let's start with KVL at loop number 1 first. Loop number 1. So in here we have, of course, this one is negative, positive, and then this one is positive, positive, negative, positive, negative, and then positive, negative. So loop number 1, so we have positive 12 volts going here. We have negative, okay, I1 times R1, negative I1. So R1 is 4. I'll put here the value already so that we can have a lesser, you know, uh, equation. And then in here, going here to here, so we now have negative I3 times R3, which is 12 ohms. And then going back to our voltage source is now equal to 0. Okay, so that is now the KVL at loop 1. So we cannot simplify this one any further since there is no similar units. Equation baliktad. EQN number 2. Okay. So, uh, did you guys get on how did we, do the equation number 2? Are we clear so far? Okay. It's 1, 2. Okay, so this is just the equation, I mean KVL at loop number 1. But how about the KVL at loop number 2? KVL, why is it lagging at loop number 2? Okay, let me just encircle this one for consistency. So in here, we're still going to use this one, and then we're still going to pass through this R1, but we are now going to pass through the R2 and then going back right here. Okay, so that's what will happen for the loop number 2. So we still have positive 12 volts minus I2, sorry, I1 first. I1 right here times R1, which is 4. And then going right here, we now have minus I2 times 6 ohms. And then going back to our original voltage source, it is now equal to 0. Okay, so we now have equation number 1, equation number 2, and then equation number 3. So did you guys get this one so far? And how did we get the equation number 3? Okay, so from here, again, you can now use this one to replace the value, I mean the variables on the equation number 2 and then equation number 3 for you to be able to get the I2 and I3 variables only. Okay, sorry, it is not the I3 right now, but it is the I1 that you have to replace. Okay, for you to be able to get the I2 and I3 on the equation number 2 and then I2 and I3 on the equation number 3. Okay,